Okay, this is 6.3. We're learning how to graph quadratics using the x-intercepts. All right, so if you imagine a quadratic equation, we know the graph of any quadratic looks like what? What's the shape it has? Okay, and
A parabola.
a parabola. Good. So we know if the a value is positive, that the parabola opens up, and if the a value is negative, the parabola opens down. Okay, but this is our shape of a quadratic. So what we're going to be learning today is if we can factor this quadratic and find these x-intercepts. Okay, because that's what we've learned how to do. We find the x-intercepts. Once we have the x-intercepts, we can add them together and divide by 2. That will give us the distance in the middle, just like how we use midpoint formula. Okay, we add them together and divide by 2. That will give us this point. Okay. So if we add these two values together and divide by 2, we'll get the midpoint here. And that midpoint we know is actually the x value of the vertex. If this is your vertex, that midpoint here is the x value of this vertex. Okay, so same thing over here. You add these two together, divide by 2, you're going to get this x value of the vertex right here. Okay, once we have the x value of the vertex, how can we find out the y value of the vertex? Matthew.
You insert the x value into the formula.
Yeah, good. You just take that x value, you substitute it into the original formula. Okay, not into your factored formula, because there could be a problem. You're always going to go back into the original. Okay, so let's try it. So the first step we're going to do, we're going to factor this. Okay. Well, actually, sorry, that's not the first step. The first thing we want to do is set this equal to 0. Okay. The reason why we do that is because we want the y value to be 0 when we're looking for our x-intercepts. Okay. So we set the equation equal to 0. Once we set it equal to 0, we can go ahead and factor. All right, so we're going to factor this. Sebastian, can you help me out? How are you going to factor that?
So you do m and a.
Okay, good, I've done that.
So it's m is 7 and a is 8.
Good.
So then you have to, so 7 divided by 1,
Yep.
and that works.
Okay, so you're going to use 1 and 7. So can I go straight to 2 sets of brackets?
Yeah,
How come?
because there's no a value.
Good, there's no a value, or the a value is 1. So now we put in x here.
So then it's x plus 1,
Good.
and then x plus 7,
Excellent. Equals?
0.
Good. All right, so we factored it now. Now to find the x-intercepts, we have to set both of these equal to 0. All right, so we're going to have x plus 1 equals 0, x is equal to -1, and x plus 7 is equal to 0, x is equal to -7. Okay, so these are our x-intercepts, -7 and -1. And we know it opens up because the a value is positive. So I know -1, 2, 3, 4, 5, 6, 7. This point and this point, and something like this. Okay? Don't know the vertex yet. But I'm going to find out. So to find the vertex, we need to find the midpoint of these 2 points. So I can find the x value. Alright, so the way we do that, now we take -1 plus -7 divided by 2. So that's going to be -8 divided by 2 is -4. So I know that this point here, this vertex, is -4 is my x value. Now I just need to find out the y value of that point. So in order to do that, I'm going to plug in -4 into x. Okay, in for x. So my original equation, I had y equals x squared, so -4 squared plus 8 times -4 plus 7. We get 16 minus 32 plus 7. That's -16 plus 7, -9. So So our vertex then is negative 4, negative 9. Alright, so then this would actually be much lower, be down here. Okay, any questions about that? So we're looking for the vertex by first finding the x-intercepts. Adding them together and dividing by 2 gives us the x value of the vertex. Okay, once we have that x value, we sub it in to get the y value into the original equation. Alright, we'll do one more example. So, who wants to help me with this? Alright, try it. What's the first step? Because we want the x-intercepts, what's the y value going to be?
Well, y value you have to multiply 2 by 6.
No, you're looking for the m. If you want the x-intercepts, what y value does it have?
That's equal to 0.
Good, so we set this equal to 0, good. Okay, now what?
And then you multiply 2 by 6,
Okay, good, and that gives us the m value is what?
12,
Not 12, but?
negative 4.
Good, negative 12. You have to take into consideration that negative sign. Negative 12, good. Okay, and add?
Or negative 1.
Good, negative 1. Okay, do you know the numbers?
12 and, negative 12 and,
No? So if you're not sure, you're going to use the method, right? Divide by 1 is negative 12. Divide by, do these two numbers make 1?
no.
No.
The opposite.
Okay, so divide by 2 is negative 6. Can you use these two to make 1?
No.
Alright, so we gotta go again. Divide by 3 is equal to negative 4. Can we use these two to make negative 1?
Yeah.
Good, so what is it?
So it's equals 2x to the power of 2 minus negative 3.
No, because you want 4 to be negative,
3
right?
and
Negative 4x and positive 3x. That make sense? Because you're taking this term and putting it into 2, right? Okay, and then minus 6 equals 0. So this is decomposition. So now we want to factor out what's common between the first two terms and what's common to the last two terms. So the first two terms, it's 2x. We're left with x minus 2. And then plus 3 is common, x minus 2. Then you're left with x minus 2 is common in both, okay? And then 2x plus 3. This is all review, right? You guys are familiar with this. Okay, so now we have two binomials, and we can set each one of them equal to 0. So we have x minus 2 equals 0. So we have x is equal to positive 2. And 2x plus 3 is equal to 0. 2x is equal to negative 3. X is equal to negative 3 over 2. Any questions there? So these are our x-intercepts. These are the x values when the y value is 0. So I know that there are 2 points on the graph when y is 0. So I'm going to add these together now and divide by 2 to find the x value of the vertex. So if I do this over here, x value of vertex will be equal to positive 2 plus negative 3 over 2 divided by 2. So this would be 4 over 2 to get a common denominator, minus 1/2 times 1/2. Alright, so then this 1/4 is the x value of our vertex. So we know our vertex. Let's erase this. Let's see what we have so far. So our x-intercepts are negative 3 over 2 and positive 2. So let's draw that out. So negative 1.5 and positive 2. 1, 2. Okay, and we know the parabola opens up because it's positive, so something like this. Okay, now we've determined that the vertex is 1/4, so here's 1/2, here's 1/4. So that's our vertex. Now to find the y value of the vertex, we take 1/4 and sub it into the original equation. So we're going to have 2 1/4 squared minus 1/4 minus 6. Any questions right now? All right, so we keep going. We're going to get 2 over 16 minus 1/4 minus 6 is going to be equal to, it's looking confusing here, 2 over 16, so we're going to find a common denominator. 2 over 16 is the same as 1 over 8. 1 over 4 is the same as 2 over 8. And 6 over 1 is the same as negative 48 over 8. And you guys could have done this on your calculator. So we have negative 1/8 minus, so negative 49 over 8. That's right. Yep. So then our vertex then becomes 1/4 comma negative 49 over 8. Any questions there? Okay, so that's kind of the lesson in a nutshell. There are a couple word problems, but they're not much difference. Okay, let's look at example 2. So we'll go over here. It says find an equation from the graph. So it shows us in a graph where there's 2 points. It tells us the x-intercepts. Well, this is a good question here. It says the x-intercepts are -2, 0, and 4, 0. And it tells us 1 point. It goes like this. It tells us 1 point over here is 2, 16. That's not the vertex, that's actually a point on the parabola, just below the vertex. And it says write an equation in the form, standard form. So it wants an equation in this form. Any idea how we can do this? Matthew.
We could start by writing in factor form.
Good, excellent. Yeah, you can start off by writing it in factored form. That's a great idea. So we're going to put the factored form here. Okay, and we know these 2 values for R and S. So Michael, what is the value of R?
It's 4.
And S?
So that's
Good. Okay, so now we're in factored form. It's all good. We're just missing that A value. Andrew, any idea how to get this? The last piece of information you have is 216, right? It's a point on the graph.
Plug in 2 to the x.
Okay, good. Yeah, you're going to plug in 2 here, but we need to do something for y. What are you going to plug in for y?
Oh, 16.
Good, yeah. So you're plugging this point in here. Excellent. So we have 16 is equal to A, 2 minus 4, 2 plus 2. So we have 16 is equal to A, -2 times 4. A is equal to -2. Any questions there? Once we have the A value, we can plug it back into the factored form, which was here. So this is going to get plugged back into here. So we'll have y is equal to -2, x minus 4, x plus 2. And right away you can see it opens down and our A value is negative. If you've got a positive A value, you'll know you did something wrong. Okay? So now we have it in factored form, but it asks for it in standard form, so we need to FOIL this. So we need to expand and simplify. So -2, I'm going to FOIL this. So and now I can distribute the 2, so -2x squared. This is -2x times -2 is positive 4x, and then positive 16. So we're done here. Any questions? Kamuka?
This is just a different question. Would you be able to go from factored form to vertex form?
Not directly. You have to go to standard form first and then to vertex form. Remember what it's called when you go from standard to vertex? What's the name for that process? When we're trying to go from standard form to vertex form, it's got a name.
Expanding the square.
Completing.
Completing the square. Good. Okay, that's right. The last question is question 3. It says design an arc. I'm just going to read through it. It says to commemorate, this is on page 287, to commemorate the 100th anniversary of the Noonville Fair, an entrance arc will be built. The design engineer uses the equation. So he uses this equation, this example 3. Uses h is equal to negative d squared plus 16. So right away, because there is a degree of 2, we know that this is a quadratic and we know it opens down. So it does look like some sort of archway. Okay? The height is h is the height in meters above the ground and d is the horizontal distance. How wide and how tall is the arch? So what are we asking for when we ask how wide and how tall something is? Yeah, Michael?
So how wide would be the distance between the x-intercepts?
Right, exactly. So you're going to find that this archway, okay, is going to have a graph that looks like this. How do we figure that out? First and foremost, how do we figure out these points? Yeah.
Factor.
Right, we want to factor this. Okay, can we factor this the way it is? What do we do? Yeah, Michael?
D plus 4.
Sorry?
D plus 4 and D minus 4.
D plus 4, D minus, like this, D plus 4, D minus 4?
Yeah.
So you're thinking difference of squares,
Yeah.
right? You're right in a sense because we can make this into a difference of squares. The way it is now is it's not because you have a square and you're adding another square,
Oh, so
right? A perfect square. So you actually have to make a little change here.
I'll make the D negative and both forwards positive.
Yeah, we have to change the sign here. We gotta make that D positive and the 16 negative, right? So in order to do that, first and foremost, we want to find out when the height is 0, okay? So before we even start that, we're going to set it equal to 0, okay? When we set it equal to 0, that gives us the liberty to do things kind of on the left-hand side, because if we do the same thing on the right-hand side, we can't just set this, start making changes to this side and not make changes to the right side. Okay, so that's why it's important that we set it equal to 0 first. Now if we multiply both sides by -1, so -1 d squared plus 16 is equal to -1 times 0.
So, be negative 16?
Sorry?
Negative 16.
No, I haven't multiplied it yet. Sorry. This is negative d squared, right? Okay, so now I'm going to multiply both sides by -1. If I multiply 0 by -1, I still get 0. If I multiply negative d squared by -1, I get d squared. And then -1 times 16, I get negative 16. Everyone follow that? Julian?
Can you move everything over to the other side?
Gonna move it all over? Yeah, you could have done that. You're right. You could have just done that from the beginning, like that, right?
Yeah.
You're right. You could have. Good thought. Yeah, you would have ended up with the same thing, right? Yep.
Couldn't you just factor out the negative?
No, because we need to get it into this form. This is called difference of squares, right? Because it's a perfect square minus another perfect square. So that's what we want. This is what Michael had mentioned. Now we can factor this to d minus 4, d plus 4. equals 0. Does everyone understand that? From this step to this step? That was one of the shortcuts we learned. Okay, now I have two binomials that are equal to 0. I set each one individually equal to 0. So d minus 4 is equal to 0, d is equal to 4, and d plus 4 is equal to 0, d is equal to negative 4. So I have my two distances, my two horizontal distances. So the total width of my archway now is going to be what? Connor. The width of the archway. So if this is one distance from 0 and this is the other, what would be the total width? So your width of your archway is going to be equal to 8 meters. All right? That's from this graph. 2, 3, 4. 1, 2, 3, 4. This distance. Okay? In order to get the height, we're going to divide these two. We're going to add up these two values and divide by 2 to get the x value. And then sub that in. The x value is actually 0. So when we sub in 0, because 4 plus negative 4 is 0 divided by 2 is still 0. So we sub in 0 for d. We're going to see the total height, or the max height of the vertex is 16. Okay, and the last part said, if a width of 2.5 is needed per lineup at the entrance, how many lineups can there be? Right, so they're saying that 2.5 is the width of a lineup. If this is an archway, you've got to imagine. So anybody have any idea how to figure that out? If this is 2.5, how many lineups can there be? Lucas, what do you think?
Divided by 2.5.
Right, you're going to take 8 and divide by 2.5. Okay, and obviously you got to round down because you can't have half a lineup. Right, unless we start cutting people in half, which would be messy. All right. Okay, that's the end of 6.3.